Hello everyone, today we will discuss a medium hard level dynamic programming problem, LeetCode algorithm problem 198, house robber. First, let's see the description of this problem. You are a professional robber planning to rob houses along street. Each house has a certain amount of money. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. For dynamic programming algorithm, we first solve small-scale subproblems and store the results. Then we use the previous calculated results to get the results for larger scale subproblems until we find the best solution for the entire problem. For example, if we are given these 6 houses, we can firstly think about if we are given only one house, 2, what is the best solution for the robbing, and then if we are given 2 houses, 2 and 7, what will be the best solution? Then 3 houses are given, 4 houses are given, until we find the best solution for the entire 6 houses. So we can see we use DPI to calculate the largest profit plan we obtained from the houses from house 0, 1 until house I minus 1. And then we will have DPI minus I plus 1 to calculate the largest profit we will obtain from houses 0, 1 until house I. For DPI plus 1, we will have 2 options. Firstly, we can rob house I, then we don't touch house I minus 1 because we cannot rob 2 adjacent houses. Then our profit will be the money we obtain from current house I, nums I, plus the money we can rob from house 0 to house I minus 2. So the best solution to rob from house 0 to house I minus 2 will be DPI minus 1. Then we have the second option. We don't rob house I, so we can rob from house 0, 1 until house I minus 1. The best solution for this robbing plan will be DPI. So for DPI plus 1, we need to find the better solution from these 2 options. So we have max from the DPI and the DPI I minus 1 plus nums I. This is the common pattern for our dynamic programming algorithm. And then we need to consider the special cases. First, we will have an n plus 1 0 array for storing our results for subproblems, where n is the length of the array, of the nums array. And DP1 will only include house 0 here, so we will provide nums 0 to DP1. And from DP2, we will have this common pattern. So our for loop will start from 1 to n minus 1. And we need to return dpn. So for dpn, we will have the best solution to rob houses from house 0, 1 until house n minus 1, which is our problem. In this way, we will finish solving this problem by using dynamic programming. Okay, let's submit our solution. Yeah, success. So we finish. Here's a trick for dynamic programming problems. We really need to pay attention to the I plus 1, I, and I minus 1. So some plus and minus will dramatically influence our results. We need to pay more attention to it. And yeah, we also need to pay attention to the special cases like for DP0. Here DP0 means we don't rob any house from the houses, and DP1 means we only rob one house, which is the house number 0. So then we will discuss the time and space complexity. Both of them are O(n) because we traverse the entire list, and which indicates we have time complexity as O(n). And we need to store our results for smaller numbers of houses. So we have the DP list, and which means we have the space complexity as O(n)2. Yeah, that's it for today. Thank you so much. Bye bye.